So to solve the first question, what is the output? Potential between 2 points is 20 volt. So V is given, delta V is equals to 20 volt. Carrying a charge 400 microcoulomb, so Q is equals to 400 into 10 to the power minus 6 coulomb. Then we have to find out what my work done. So work is equals to tension time. So delta V is equals to work upon Q. So work is equals to delta V Q. So this is equals to 20 into 400 into 10 to the power minus 6. Whose answer is how much? 8 into 10 to the power minus 3 joule. That you got it.
Yes, ma'am.
Next question is saying it what? That 100 joules of work, joule and it means it is a work. So work is equals to 100 joules. From where to where? From move an electric charge of magnitude Q value is given. Q is equals to 4 coulomb. From place A, यानी कि A to B. Work is done from A to B, where the potential is minus 10 volt. So my BA is given minus 10 volt because it is point at the place A, whose volt is this one. Now another place B, the potential is B. Okay. So VB is equals to V volt, which is equals to that we have to find it out. Okay. So our formula is what? By V VP is my final. VP minus VA is equals to, how we can find it out? From work also. Work is from initial to final. So final will be what my V. And potential is from the final to initial. So that is the easiest way to find out. So this is equals to work A to B divided by my Q charge. VP is equals to V minus 10. VB we have to find out. This is what my minus 10 microcoulomb. So minus 10 microcoulomb is equals to 100 divided by my 4, which is equals to V minus minus get plus 10. 100 divided by 4. So it will be how much?
25.
4, 4 is the 8, 4 5 is 25. Okay. So V is equals to 25 minus 10, which is equals to how much? 15 volt. We got the answer. Now, the next topic. Write the next topic here. The next topic is what? By electrostatic potential due to a point charge. Okay, due to a point charge, what is going to be electrostatic potential? That we have to find it out. Okay. Okay. So we have to find out the electrostatic potential due to a point charge. Suppose this is my Q charge separated by r distance to a point P. Then how much is the potential at this point P? That we have to find it out. Now how to find? Suppose this is my mobile bank. Okay, then power bank. Suppose this is my power bank. It is totally it has no charge, and this is my mobile phone carrying some charge. Now power bank and mobile phone is separated by a distance r. So mobile power bank is not so much charge. Now I have to charge it, and this mobile phone is also taking the charge from the power bank. So what to do? We have to take a charge from the infinity, that is from the socket. Correct? From the socket we will charge our power bank. Work will be from what? Infinity to people. Okay? Then my mobile phone will also charge. Now how much work we are doing, because we know the formula that potential is equals to work upon discharge. Then we don't know how much work we are doing here. Okay, now what to do? But we know. One thing we have to remember it by heart, that whatever the charges or whatever the work that we are doing it here, that test charge. Suppose if you are charging a mobile phone, it doesn't mean that the mobile phone just charges within a second. Just like you can say your washing machine is working immediately, then your TV also works immediately, right? But mobile phone is not charging immediately. It takes time. Why? Because the charges are moving very, very slowly. The electrons are moving very, very slowly, so that it will not gain kinetic energy. Kinetic energy will not gain. Kinetic energy is always remaining as light zero. That's why it takes half an hour, 1 hour to charge your mobile phone. So how much work we have to do so that the electrons will go from infinity to source point B without gaining the kinetic energy in by uniform electric field. That we have to find it out. Now, what to do? We can't able to find out the work done from the infinity to point. This is totally impossible because it's the infinity charge. Now what to do? I will take my test charge and I will go to the infinity. This work I can able to do, and that work will be what by along the electric field. That's going to be what negative. Any doubts on anything?
No, ma'am.
Now, how much work we have to do for that? If suppose this is my charge along the electric field, it will go immediately with the electric current, right? So we don't want to gain the kinetic energy. So from backward, we will give some force, right? From backward, we will give some force. That is my external force.
Why, ma'am?
So that the charge will not gain the kinetic energy. Just
Yes,
like my
ma'am.
tug of war. One kids, two, three kids are here, two, three kids are here. There is a rope. The rope should have to maintain up at the center line. This is my center line. Then both the kids are pulling with each other so that the rope will remain at the center line. It is same like this. If the charge gains the kinetic energy, we will just give the external force the backward direction. No, you don't have to gain it. Understood? Like this. Now this external force is equal to what? My Coulomb's force. Because this is an electric field. So F external is equal to my F electrical, which is equals to what? K Q upon R square. And R is how much, my? This one. From here to here. Suppose I have taken the x distance. And this is my dx. Okay. So the charge will be what? X square. Any doubt, beta?
Ma'am, I can't understand force external.
Okay.
Can you increase the voice, ma'am? I can't hear properly.
Okay, fine. It's a lot. I will increase the volume. What you didn't understand, first you tell me that.
Why the force external is coming?
Force external is coming just because, just as we like tug of war, we are doing what external. Both the case of Pakistan are doing what forces so that the rope is released at the center, right? Right, Pita?
Ma'am, your voice is very low, ma'am.
Once I'm saying it out, wear your headphone, Pita. Wear your headphone. Here, here.
Ma'am?
Now it's audible.
Yes, ma'am.
Just like my tug of war, what we are doing in my tug of war. Suppose here is also kids and here is also kids. This is my row. And this one is the center of the line. No one has to cross the line. So what we will do? If this is my work, here kids will pull in this direction, this kid will pull in this direction. Now it is what totally in equilibrium state. Both the forces are what same direction. So the body is in what equilibrium state, right? I hope so. You have played tug of war. Nandu, is it clear?
Yes, ma'am.
Similarly, if this is my work done by my charge, this is my work done by my charge, okay, and this is the work done by my external force. Okay, so what will be happen? This is my external force. This is my work done from where, from infinity to point P. So both the charges are in equal and opposite direction. So the charge will not gain my potential energy, sorry, kinetic energy. It will not gain. So the charges will move very, 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 very slowly. Because if I will not apply the external force, the charge will go in this direction very fast because this is my electric field. This is my electric fields. Okay. So it will go very fast. And what will happen? The circuit will burn it out. Because charge is having a heat. Understood now, Nandini?
Yes, ma'am.
Very good. So because of that reason, suppose if I'm saying this is my R, okay, I'm just taking it here also R. So from here to this point, I'm also taking it was my R. So it will be what? KQ by R square. This is my electric field. Now, this electric field is what making an angle with my work, that is my 180 degree. Totally 180 degree. Any doubt?
No, ma'am.
Now, work is equals to what? My force into displacement. Work is from where to where? From T to infinity is equals to Fp into dr from where to where? From P to infinity. Okay, and Fe is how much? My this one. That is okay. I'm not taking my test charge also. Suppose I am taking this as a test charge and this is my Q charge. This one. Okay. Now my test charge multiplied by Q. So this is equals to from P to infinity. Just put the value of Q. And for work is equals to force into displacement. That's why I have taken it as a D R. Okay. So this is equals to K Q Q naught upon R square dr. So this is K Q or Q naught constant taking outside K Q Q naught from where this will become what? Minus 1 upon R after doing the integration, correct? R minus 2 plus 1 divided by minus 2 plus 1. This is equals to r minus 1 divided by minus 1. This is equals to minus 1 upon r. This is my integration form. Is it clear, Nandini?
Yes, ma'am.
From where to where? From p to infinity. So this is equals to k q q naught minus 1 upon infinity, minus minus get plus 1 upon r, 1 upon r. So this is what infinity is always my 0. So this is equals to k q q naught by r. So this is my work from where? From my p to infinity. But what is my potential formula? So my potential formula is work is equals to from infinity to p is equals to minus of from minus of, and this is here is a minus sign. Yeah, this is good. So minus of work external to from p to q. Sorry, p to infinity, which is equals to k q q naught upon r square. Is this clear, Nandini?
Yes, ma'am.
Huh? Fine. And here, right, it is making an angle cos theta also. Now I have forgot to write it. This is my dot product. That's why I'm thinking that why it is making an angle problem. This is cos 180 degree because I have right now we have explained it that the FE and D are making, and this force and D are making an angle what 180 degree. Cos 180 degree is what minus. Okay, so it will be what minus external from p to infinity is what my minus sign. So infinity to peak will be what my positive. That is this much, and potential will be from where to where? Potential will be from my p to infinity, because this is what infinity to p. So potential will be from p to infinity is equals to work infinity to point p divided by my test charge q naught. So this is equals to k q q naught by r square multiplied by q naught, which is get cancelled. That is equals to k q by r square. So this is an infinity potential is what always 0 because we can't able to find it out. Is this clear, Nandini? So
Yes, ma'am.
Vp is equals to kq by r square. This is the potential at the infinity point. Sorry, for the point charge, not the infinity. For the point charge. Clear?
Yes, ma'am.
Okay.